tsunami waves would arrive on the Washington coast.
It's a very strong earthquake.
Yep, we're having an earthquake.
Scientists have known for a long time that there will be a huge 9.0 magnitude earthquake that will come from the Cascadia Fault in the northwest Pacific and quickly send huge waves crashing into land. Imagine that these predictions were wrong because they were missing a crucial piece of data that, in some cases, could reveal an even scarier tale. A new study that came out last month in the peer-reviewed journal Earth Science Reviews points to this kind of missing piece. Researchers found a link between something called the outer wedge, which is the area between the main earthquake fault and the seafloor, and how strong a wave is that is caused by an earthquake. A co-author of the study named Sylvain Barbot called the outer wedge the garbage bag of subduction zones. This is where two tectonic plates crash into each other, which can cause an earthquake, because that's where the silt piles up. Scientists have found that the biggest wave that can happen will be bigger if it's wider. The link adds a new factor to think about when predicting tsunamis, and the authors say it might mean that the worst-case scenarios for some faults, like Cascadia, are predicted with greater certainty. A professor of earth science at the University of Southern California named Barbot said, "There are places where the outer wedge is very small, which is great news. And some places it's really big. That's also true in the Northwest Pacific." He and Qiang Qiu, who is also an author, looked into 11 tsunami earthquakes that have happened around the world in the last 200 years. They did this over the course of about 2 years. These are very rare events that involve earthquakes that aren't very strong. The authors looked at ones that were 7.1 to 8.2 on the Richter scale, but still cause huge tsunamis that have scientists puzzled for a long time. They found that the highest point of the wave and the outer wedge were related. Barbot said that the more faults there are and the wider it is, the more likely it is that the seabed will move, which means that the tsunami may be higher. Imagine a bookshelf full of books, and you take the books and you tilt them all 45 degrees. The interface between any book is a fault. And so, in an outer wedge you have all of these books and all of these faults in between. And they can provide a pathway for the rupture to go up, instead of going left, he said. Based on what they learned, they were able to project tsunamis in dozens of other active subduction zones around the Ring of Fire, a path that runs for about 25,000 miles, and is where most of the world's earthquakes happen. The 600-mile Cascadia earthquake zone was somewhere near the top of that list. From Canada's Vancouver Island to Northern California, it goes along the fault line. The next big earthquake is about to happen. About a 15% chance of a 9.0 magnitude earthquake happening in the next 50 years is what scientists think. The last big one happened in 1700. Many people learned about the subduction zone from a 2015 Pulitzer Prize-winning piece in The New Yorker. The author called the next big earthquake there the worst natural disaster in the history of North America, outside of the 2010 Haiti earthquake. The authors say that the site has a pretty big outer wedge that runs for 15 to 43 kilometers. From what they've learned, that means the tsunami caused by the earthquake could go higher than 200 feet, 61 meters. There are a lot of different estimates for the big one, but that is about twice as high as some of the worst cases that have been thought of before. The study's authors looked at 30 other subduction zones and ranked them by how bad their tsunamis were. Cascadia came in at number 5. They say it's behind the subduction zones of Makran in Pakistan and Iran, Aleutian in Alaska, and Lesser Antilles in the Caribbean. Barbot said that the results need to be checked out more. However, they could change not only how tsunamis are predicted, but additionally how people in these areas get ready for emergencies. If you're ready for a 30-meter tsunami and a 60-meter one comes through, you need to make your evacuation zones twice as high, he said. You need to change your mind about where you want to put hospitals, schools, and other public buildings. In a more realistic sense, it also changes the price of real estate insurance mostly. Basically, it changes the risk and how it's spread out in space. Of course, this outer wedge isn't the only thing that can change how big a wave is. The slope of the seafloor and the general shape of the land are some of the other things that affect this. Harold Tobin, who is in charge of the Pacific Northwest Seismic Network and teaches Earth and Space Sciences at the University of Washington, said that this study shows an interesting new result, but that more research is needed to fully take these other factors into account. He said it was too early to draw any conclusions or start changing how people in the Pacific Northwest or other places get ready for tsunamis. Tobin said, "What we need to do is use the evidence in this paper to make better models for all of that, to narrow down and improve the scenarios that are being planned for. But by itself, that doesn't mean we need to say, okay, there's twice as much of a risk of tsunami as before. It only shows one way that the earthquake risk might be higher than was thought before." And now, let's see what is the worst-case scenario if the 1700 Cascadia megathrust earthquake would happen again. Let's take a closer look at what might happen on the Cascadia margin. A 9.0 magnitude earthquake shakes the plate border, causing a 1,000 kilometers long crack and a lot of movement up and down. A wave that moves at 800 kilometers per hour is generated by this. People living near the coast will feel the quake waves first. They will be between 7 and 8 on the magnitude scale. This strong shaking will bring down old buildings that weren't built well, bridges and other structures. It will also cause landslides and soil liquefaction, which is when wet soils behave like jello, which will trap people and make it harder to help them. But everyone on the coast will know that things are about to get worse and that they need to leave as soon as the ground stops moving. Land along the coast could sink by up to 6 feet, 2 meters, because of the deformation that happens along the plate boundary. This makes the coastal area much more likely to flood. In about 15 to 20 minutes, the first tsunami wave will hit the coast from Victoria Island in Canada to northern California. This won't give people much time to get to higher ground. When the waves hit the coast, they might be 30 to 40 feet, 9 to 12 meters high, but some models say they could reach 100 feet, 30 meters. They would flood up to 10 miles, 16 kilometers, inland in many places along the coast. Some parts of the coast are much more likely to be flooded by a tsunami than others. People who live in these areas will need to get to higher ground very quickly after the earthquake waves stop. Due to their very long lengths, the waves will keep coming, and the water will not rise for hours. At some point in the future, such a catastrophe will occur along the Cascadia margin. The damage and effects will rely on how the earthquake happened and where it happened, how much the coast sinks, how much damage the earthquake did, and how high the tsunami waves are. Good news though is that people are becoming more aware of important issues. A lot of news coverage has been given to this issue, and local governments have been putting a lot of money into projects to make communities safer. As Nathaniel Philbrick says, in all natural disasters through time, man needs to attach meaning to tragedy, no matter how random and inexplicable the event is. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more, and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.